A magnitude 2.6 earthquake in northwest Georgia this morning. So we want to know more about why are earthquakes more common in that part of the state than other regions in Georgia as well. Joining me now, Professor of Geophysics at Georgia Tech, Dr. Zhigang Peng. Thank you so much for joining me today.
Sure.
So
my pleasure.
Tell me a little bit about this earthquake that occurred first thing this morning, 8 o'clock up in Chattooga County. Is this a common area for earthquakes in Georgia?
Yes, I think that you're right. This earthquake, as you mentioned, occurred near the border between Georgia and Alabama. But if you look at what happened in the past like 20, 30 years, there appears to be a diffuse zones of seismic activity along that region, further extended along into the border with Tennessee. So we call that as the Eastern Tennessee seismic zone. And yeah, there were quite a bit of small earthquake occur in that region over the past 2 decades.
And the Eastern Tennessee seismic zone, for people who don't know what that is, can you explain why we see more earthquakes there in parts of Eastern Tennessee, northeastern Alabama, and northwest Georgia versus other areas in the southeast?
Yeah, that's a great question. I think we still don't know exactly why, but we do know that if you're looking at, again, in central and eastern U.S., we typically have about, especially in the south, there are 3 seismic zones. Obviously, the so-called Eastern Tennessee seismic zone is in the middle, but if you look to the west, we have the New Madrid seismic zone, and then further to the east, near the South Carolina, we also have the Somerville-Charleston seismic zone. And one thing we think the reason why those seismic activity over there is perhaps because either there were historic large earthquakes there, so some of those events we're seeing today could be an aftershocks of those very large events. This was actually the case for the Charleston because there was a big earthquake in 1886. We're not 100% sure why we do have those earthquakes that are on the scales of about 50 to 80 kilometers wide and about 300 kilometers long along the Eastern Tennessee. So there has been quite a bit of studies looking into this. I don't think we have figured out the exact reason why they are there yet, but we do know that earthquakes along that section seem to occur more often than the rest of the southeast.
And part of the pieces of the puzzle to figure out why they're happening is mapping them, right? You've recently been a co-author on a study where you actually plotted a lot of this seismic activity happening there in the Eastern Tennessee seismic zone. Can you tell me more about that study that you did?
Absolutely, yes. So this was a study we did a few years ago with my former student, Clara Daniels. And what we were doing in that study was basically to connect all the seismic data that has been recorded in that region over the past 15 years or so. And then we carefully relocate them, basically try to figure out a way to determine exactly where they're located. And after we did that, we found out that many of them occurred in small kind of lineament, which is probably an indication that there are some small faults that are active in those regions. But again, the million-dollar question we still couldn't figure out at that time is why they occur in that region rather than other places.
Yeah. And you said smaller faults. So the earthquake that occurred early Tuesday morning up in northwest Georgia, would that be along one of those smaller faults that's a little more active than other areas?
Possibly. Of course, we have not looked at this event carefully yet, but with the magnitude, and also I should point out that this event is probably the most recent event was probably only a few kilometers away from another slightly larger event that occurred in 2003, I think near Fort Payne in Alabama, which is near the border. And they're probably not on exactly same fault, but there are probably multiple possible small fault segments in that region. Again, the question is what activated them, because we have a lot of old faults in this part of the world. Most of them are not active. There was only a handful of them that somehow decided to be active and generating some of those smaller seismic events.
So maybe waking up some of those smaller faults. Now, this was pretty weak and also pretty shallow. Is that how you would characterize rather a lot of the earthquakes that happen in this kind of ridge and valley portion of Georgia?
Exactly. So as you already kind of point out, most of the earthquakes in the eastern Tennessee seismic zone are occurring actually near these provinces called region Valley and Ridge. Um, and it turns out that actually most of the events are slightly deeper. For example, in the depth ranges about, like 10 to 20 kilometers or so. This event, I believe that the depths, the current determination is about 9 or 8 kilometers, but one should look into it carefully to determine whether or not, the depths could be further refined. But this is kind of the typical range of the event occurring in this region.
And for those who are not very familiar with earthquake science, how do we measure how strong an earthquake is? Can you tell me about the scale that measures that?
Absolutely. So the standard or the typical measurement we normally use is something called Richter magnitude. But basically what it is just measure the amplitude. That is how much of shaking, what's the maximum amplitude during that particular event. And then you have to do some correction, such as distance and other effect, so that you can get a measure which is called magnitude. And just one thing to be note for your audiences is that magnitude scale is what we call logarithmic scale. So in that case, sometimes if you have a very small magnitude, you can actually end up getting a negative magnitude. It just means that it's a very small. And now typically, I would say that in, let's say, Georgia, if it's a magnitude 1 or 2, it can be felt within a couple of tens of kilometers. But if it's something slightly larger, like for example in the case of that Fort Penn earthquake occurring in 2003, I believe was widely felt even in Atlanta as well.
Right. And you said this was located near the Fort Payne earthquake. Is there any, I know you haven't dug deeper into today's earthquake, but is it possible there's still aftershocks occurring, that this could maybe be one of those from that earthquake over 20 years ago?
That's a great question. And actually, I did look briefly at the map. Now, my understanding is that the distance, if the location of today's event is accurate, I believe there are about 5 to 10 kilometers. And so it's kind of near that, range where it's probably not exactly in the same aftershock zone. However, when I look at, again, the USGS official map, I did find quite a few of the, earthquakes occur near the epicenter of the Fort Payne earthquake that occurred a few years later. So I think it's too early to either confirm or rule out whether or not this event was part of the aftershock sequence. But we do know that, especially sometimes in kind of the central and eastern U.S., sometimes seismic activities, aftershocks activities can lingering for years or sometimes tens of years.
And
so
why
it's too early
is that?
to talk, but it's very close.
And why can those aftershocks be many, many years later? What does that have to do with the rock that's under the ground?
That's another excellent question. So we thought that basically has to do with the following facts. That is, generally speaking, if a region that are loaded very fast, for example, let's look at the case of California or Japan or any other, we call it tectonically active region, if they are loaded very fast, then their aftershock duration is typically much shorter, typically on the order of years and most tens of years. But if you're looking at regions such as here, we call it intraplate region. In those cases, the tectonic loading or the string accumulation is very, very small or subtle. In that case, when you have even like a magnitude 4 or 5 event, that the aftershock activity sometimes can last for quite a long time, because it was again inversely kind of proportional to the loading rate. So the faster you load, the shorter the aftershock duration.
I think of the 5.7 Mineral Virginia earthquake still having aftershocks over a decade later. Let's pivot a little bit, Dr. Peng. You do a lot of research at Georgia Tech. You all have earthquake sensors on campus, but just this past year in 2024, your research took you to a new area of the metro up near Lake Lanier, where we had this swarm of earthquakes. What can you tell me about you and colleagues at other universities doing to try to get to the bottom of what was causing all of those seismic tremors, rather?
Exactly. So as you recall, that there was a relatively small earthquake swarm that occurred, I think it was around mid-June of 2024. And so we rushed there. We deployed about 8 sensors in that region, and we actually just retrieved the sensor about a month or two ago. And when we look at the data, and we did find a few additional events that was actually captured by our network. However, and this is like some of the other cases where when we started putting sensor there, it kind of literally shut down the sequence. So there were no, since we deployed the sensor in mid-June, there were no officially reported earthquakes. And like I said, we found a few more, and we're still trying to figure out, using additional analysis to identify more events. But at least from what we have seen so far, it appears most of the events were actually occurring further north, almost probably near or within Lake Lanier. So we still need to detect more or find more events in order to identify which are the fault line that was activated. But I think it's too early for us to tell anything at this point. And I will definitely keep working on those data sets that we connected last summer.
And a good collaborative study with other universities from across Georgia. Is there anything else you want to add about today's earthquake and what people should know about earthquakes in general, the risk of earthquakes here in Georgia versus other parts of the country?
That's right. So I think, again, for your audiences that, people here in Southeast are not used to, experiencing earthquakes. So there might be a period of anxiety and wonder what's going to happen next. For event like this, in most cases, they are, occurring, and in most cases will be followed by a few smaller magnitude event in that region, and then they will mostly quiet down. That's typically the case. Another thing to keep in mind is that because rocks, beneath us here in the East Coast is much older and stronger, so that whenever you have an earthquake like this, it actually can be felt at much wider distance. So even though the activity here in Southeast United States is much smaller as compared with, let's say, Western United States, whenever there is an earthquake, that will be felt at much wider distance. So in short, I think it will be useful to know that what to do if in case you are experiencing an earthquake. So we call that as drop, cover, and hold on. So in particular, that if you feel shaking, do not run towards the door or don't go outside yet, because most times you cannot, you don't have enough time. But instead, the best way is to find a place, like underneath a table or somewhere where you can hide yourself. Once the strong shaking is over, then you can leave the building. I hope that in most cases you probably don't need that, but in case needed, that would be the way to prevent you from getting injured during earthquake activities.
Excellent advice. Many of our earthquakes, most of them are all very small, but there's that small risk that there could be something larger. So we practice those tornado drills in school, but we don't practice the earthquake drill. So thank you for explaining that to all of our viewers today. Dr. Zhigang Peng with Georgia Tech, thank you so much for joining us.
You're welcome.